All right, guys, as promised, I'm back with Standard 4 Part 2. I'm going to focus specifically on cladograms and phylogenetic trees. I think this is 4.2 or 4.3, not exactly sure right now. But anyway, cladograms and phylogenetic trees are both used to show relationships between different organisms, different species. Now, a cladogram is based off of the emergence of characteristics or traits, and it is not based on the time from which something diverged or when it evolved from a common ancestor, whereas phylogenetic trees do show the time of divergence from common ancestors. With phylogenetic trees, the length of the line actually matters, whereas with cladograms, it does not. Now, the thing that they both have in common is the closer two organisms are on a cladogram or a phylogenetic tree, the more closely related they are. So basically what you're looking at with a cladogram is you're going to have a line, and on that line you're going to have characters, and these characters are basically things like traits. So it may be something like having a backbone, or giving birth to live young, or having feathers, or having four limbs. Whatever the traits are, they will be on this line. Across the top, you're going to have the names of the different organisms, okay? So basically the way a cladogram works is when a trait shows up, everything after that trait will have it. So in this case, organism E would have traits 1, 2, 3, 4, and 5. Organism D would only have traits 1, 2, 3, and 4. Organism C would have traits 1, 2, and 3. Organism B would have traits 1 and 2, and A would only have trait 1, because the trait 2 came after organism A appears. Following? So the trait, wherever it shows up, the organism that comes after that trait has it, not the organism that comes before it. So on this particular example, E would be more closely related to D than it would C, because it has more in common with D than it does C. So you're basically looking at how close they are together, and the closer they are together, the more related we say that they are. Now, this cladogram, notice, does not show anything about ancestry. It doesn't say what the common ancestor is. All it is showing is that this organism B, has traits 1 and 2, whatever traits 1 and 2 would be. So the organism with the most traits would be on the one end. The organism with the least traits will be on the other end. And it's the opposite for traits. The first trait should be found in the most organisms, and the last trait is found in the least organisms. Now, a phylogenetic tree, on the other hand, actually shows divergence from a common ancestor, and these little dots represent things called nodes, and the nodes are there to represent a common ancestor. And we show divergence, which means one species diverged or split into two or more different species. The common ancestor for everything, every species on here, every organism on here, would be the very first at the beginning here. So this will be the common ancestor for everything. Now, whatever this evolved into, this is going to be the ancestor number 1, it diverged into 2 in organism E. Organism E did not evolve again, but 2 evolved into 3 first, and then 4. Remember, the length of the line matters here. So since line 3 is shorter than line 4, that means that there will be evidence that whatever organism 3 is, it appeared in our fossil record, or whatever record we're using, it appeared before organism 4, because that line is shorter. Whatever 3 was diverged into organisms A and B, and whatever 4 was split into C and D. So if I'm looking at organisms C and D, the last common ancestor they have in common is here at 4. But if I'm looking at C and B, their last ancestor in common would be back here at 2. So this is how a phylogenetic tree works. Phylogenetic trees actually show common ancestors. The length of the line represents time, so it's showing the time of divergence from that common ancestor, whereas cladograms are only showing the emergence of different characters or traits, and which organisms actually have those traits. That's it. Toodles.